Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
Mars is more like Earth than any other planet in the solar system. Is there water? Is there life? Want to find out more about Mars? We're here to answer your questions. Stay tuned. Science Trek is next. Hi, I'm Joan Cartan Hansen, and welcome to Science Trek, and welcome to the Boise Art Museum. Here, artists Nicholas Kahn and Richard Selznick have taken pictures of the Craters of the Moon National Monument and morphed them into what they think life on Mars might be like. But of course, our guest scientists know what it's really like on the red planet. But before we answer your questions, let's learn a little bit more about Mars. Mars is the fourth planet from the Sun. Of all the planets in the solar system, Mars is the most like Earth. Mars spins on its axis with a tilt similar to Earth's. A Martian day is about 24 hours and 40 minutes. It has distinct seasons, and there are ice caps on its north and south pole. But unlike Earth, Mars has a thin atmosphere, mostly made up of carbon dioxide. Mars is about half as wide as the Earth, and because its mass is lower, it has far less gravity. If you weighed 50 pounds on Earth, you'd only weigh 19 pounds on Mars. And because Mars is much further from the Sun than the Earth is, Mars takes longer to orbit the Sun. A Mars year takes 687 Earth days. Its average surface temperature is about 80 degrees below zero. Summer days can get much warmer, but because Mars has so little atmosphere, the nights are very cold. Mars has two moons, Phobos and Deimos. They are small and shaped kind of like potatoes. Deimos is the smaller, and its orbit is farther from Mars than Phobos. Phobos can orbit Mars 3 times in a single Martian day. Mars was named after the Roman god of war and is known as the Red Planet. It's red because iron in the dirt on Mars gives it its rusty red color. Mars has giant volcanoes and deep canyons. The highest volcano in the whole solar system is Olympus Mons, and it's on Mars. Olympus Mons is about 374 miles wide and 16 miles high. That's 3 times taller than Mount Everest, Earth's highest point, and about as wide as the state of Arizona. There are lots of craters on Mars caused by asteroids, and Mars's surface is solid like Earth's and made up mostly of rock and dirt. Giant dust storms can blanket much of the planet and leaves the Mars sky a pink or tan color. In 1877, Giovanni Schiaparelli first identified lines on the surface of Mars. He called them canali, which was mistranslated into English as canals. Astronomers of the time thought the canals had been dug by some sort of alien life form, and that started the talk about little green creatures from Mars.
At last, the secret was mine. And now, to get proof of my discovery, smuggled past the border guards. In spite of my infinite precautions, one of them became suspicious and gave the alarm.
Come back for the eggs, did you? Yeah.
And so, with the fond farewells of the natives ringing in my ears, I took off once again for Mars.
Well, there were no little green Martians when Mariner 4 took these first real close-up pictures of the surface of Mars in 1965. Viking 1 landed on the surface of Mars in July of 1976 and provided the first panoramic photos of the planet's surface. And rovers like Spirit, Opportunity, and Curiosity have allowed scientists to learn a great deal more about the red planet. We know water once ran in streams on the planet, and there were once lakes. We're studying the elements that make up the rocks and soils on Mars, and we're searching for the building blocks of life. And who knows? Maybe you'll be the first astronaut to walk on Mars and discover even more about the red planet. And joining me now to answer your questions about Mars are two scientists from the Jet Propulsion Laboratory in California. Matthew Haverly is a mobility systems engineer or a rover driver for the Mars Science Laboratory mission, and Todd Barber is a propulsion engineer working on the Cassini mission to Saturn, who also worked on the Mars Science Laboratory. Thank you so much for joining us. Okay, let's go to your questions.
Hi, my name is Josue. I go to Cynthia Mann Elementary School, and my question is, how big is Mars?
The quick answer is Mars is about half the diameter of Earth. So if Earth's diameter is roughly 8,000 miles because its circumference is 25,000 miles, Mars would be about 4,000 miles in diameter. Earth's smaller cousin, the next planet out from the sun.
Hi, my name is Ellie, and I go to Owyhee Harbor Elementary. And my question is, why is Mars hot when it is far from the sun?
Mars actually isn't that hot. Mars is actually pretty cold during the daytime and the nighttime. So one of the great things about Curiosity is we actually have a weather station on the rover, and it sends me tweets to my phone every day with a weather report. So on Sol 357, where a Sol is a Mars day, so this is 357 Mars days after landing, the high was -7 degrees Celsius and the low was -76 Celsius. That's 19 and -104 Fahrenheit. So it's actually really, really cold on Mars, and that's one of the challenges that we always have to deal with when we're designing our rovers, is they have to survive those really cold Martian nights.
Hi, my name is Chloe, and I go to Owyhee Harbor Elementary School, and my question is, what causes Mars to be sphere-shaped?
Hi, Chloe. That's a great question. It's essentially the force of gravity, and that's why all the large planets are basically like a sphere. If a body's really small, like one of Mars's moons, Phobos and Deimos, they're irregularly shaped, probably captured asteroids. Those aren't big enough for the force of gravity to melt the interior and form it into a ball. But essentially, nature tries to minimize energy. It wants the minimum surface area for a given volume, and that's a sphere. So that's why we see this in the planets.
Braden asks, if water was on Mars, could you live on it?
What we found with the water that we see that used to be on Mars, one of the great discoveries that Curiosity made was that water was water that you or I could have drank. The water that previous missions have found looked to be really acidic, but the water that Curiosity found looked to be just like streams and rivers that are here on Earth. But because it's no longer there, there's no longer any water on the surface of Mars. And there's a few other things that make it so that people would have a hard time living there. One is the temperature. It's really cold, even in the daytime. It's really, really cold on Mars. It rarely gets above freezing. And another problem is the atmosphere. You couldn't breathe on Mars. We'd have to live in spacesuits just like astronauts that would go to the moon. So even though Mars used to look like a place that was maybe a little bit more inviting to people, it's not a place now that people could live.
So what happened to Mars? Why is it no longer habitable?
That's the question of what all the scientists are trying to answer. Why did Mars change? We know that it used to look much warmer and wetter than it does today. And we don't really understand why that change happened. And unlocking the secrets of why Mars changed can potentially help us understand why the Earth is changing. And we just want to be able to understand that change in a much deeper way.
Hi, my name is Ike, and I go to Cynthia Mann Elementary School. And my question is, how hot can Mars get?
Thanks. That's a great question. Even though Mars generally is a very cold planet, particularly at night, if the conditions are just right, you can actually get some temperatures that are rather pleasant. If Mars is as close as it gets to the sun in its elliptical or egg-shaped orbit, and if it's about noon, and if it's the middle of summer, and you're on the equator, a lot of conditions. But in those four conditions, the temperature can get to 75 or 80 degrees Fahrenheit. That is room temperature, 25 degrees Celsius. So almost toasty.
Hi, my name is Junior. I go to Cynthia Mann Elementary School. My question is, how many volcanoes are on Mars?
Good question, Junior. We're still trying to map out all of the geological features on Mars. But one of the things we know is that there used to be a lot of volcanoes, but now there's no active volcanoes on Mars. Olympus Mons is the tallest mountain on Mars, which used to be a volcano. And what we see with some of our rovers is we see lava flows and other evidence that there used to be active volcanoes spewing lava all over the surface. But all of those have now gone extinct, and we don't see that active lava flow or active volcanic action anymore. So we're still trying to understand what happened and why that change was made, but right now, no volcanoes on Mars.
Hi, my name is Claire. I go to Cynthia Mann Elementary School, and my question is, how many moons does Mars have?
Turns out Mars only has 2 moons. Of course, that's one more moon than we have here on the Earth. The names of the moons are Phobos and Deimos, and those are the Greek words for fear and panic. And we believe they're probably captured asteroids. These are really tiny bodies, just a few tens of miles across at most, and they're irregularly shaped, heavily cratered, and they've been orbiting Mars for some time. The reason we think they're captured asteroids is between Mars and Jupiter is the asteroid belt. So asteroids are nearby Mars. A couple might have got too close and got captured by Mars gravity. Thanks for a great question.
Gracie would like to know, what are the different layers inside Mars?
The layers inside of Mars are a bit of a mystery, as they historically were on Earth. However, we do think that Mars probably has the same kind of structure as Earth, a core, a mantle, and a crust. One thing we can do, and we have a mission called InSight that will be landing on Mars just in a couple of years, we can put seismometers down and actually listen for Mars quakes. There are small Mars quakes just like there are earthquakes. And from that seismometer data, we can see how waves move beneath the surface and actually map out how the different layers of Mars came to be. And that'll give us a lot of information about how Mars itself formed and evolved.
Mars has an enormous canyon called Mariner Valley. It's 4 miles deep and an astounding 2,500 miles long. That's as long as the entire continental United States. It's the longest known crevice in the solar system.
Hi, my name is Con and I go to Hawaii Elementary School. My question is, does Mars have water?
One of the things we found with our rover missions is we found past evidence of water. So Spirit and Opportunity, as well as Curiosity, have all found really clear evidence there used to be flowing streams and rivers on the surface of Mars. And the Phoenix lander, which was a lander that landed near the pole, the North Pole of Mars, actually dug down and found ice, water in the form of a solid, underneath the surface. We know that water can't exist with the conditions on Mars today on the surface as a liquid. It would automatically go from the solid up to a vapor and it would evaporate. But we know that back in the past, way back when Mars was a very different looking planet than it is today, that it had streams and lakes and rivers flowing all over its surface.
Hi, my name is Stelton. I go to Hawaii Harbor. My question is, was there life on Mars?
The short answer is we don't know yet. However, billions of years ago, Mars was warmer and wetter. We have a lot of evidence that liquid water was on the surface, even flowing. Curiosity has told us that. So on Earth, wherever we find liquid water, a source of heat or energy, and some organic molecules, life is abundant. So the real question is, did life start on Mars? And we're talking probably microbial life, single-celled organisms. But Mars seems to be a pretty inviting place, at least billions of years ago, for biology to take hold. So that's why we do these rover missions, is to answer just that question.
Hi, my name is Kaya, and I go to Dalton Elementary in Dalton Gardens, Idaho. My question is Mars red because the rocks are made of iron oxide?
Kaya, yes, you've hit it exactly on the head. Mars is red because of iron oxides. It's essentially like good old rust on the Earth. When you have metal in an oxidizing iron in an oxidizing environment, which is what apparently Mars had early in its history, that tends to form these iron oxides, which do have that reddish, rusty color. You can even see that if you look up at Mars in the night sky, even without a telescope or binoculars.
Hi, my name is Henry. I go to Cynthia Mann Elementary School, and my question is, how many probes have been sent to Mars?
It's a good question with a little bit of a complicated answer. There's been people since the 1970s that have been trying to send things to Mars, both the U.S. and Russia. And total, there's about 30 or 40 probes that we've tried to send, but not all of those have been successful. About 2/3 of everything we try and send to Mars doesn't work. It doesn't get out of the Earth's orbit, it misses Mars, it crashes when it tries to go there. The U.S. started with orbiters around it, and we sent Viking 1, which was the first lander to land on Mars. And lately we've had a lot of success with the Pathfinder mission, the Phoenix lander, and the North Pole of Mars, the orbiters that we've sent, the twin rovers Spirit and Opportunity, as well as Curiosity. And we hope to continue on increasing our rate of success as we try and land things on the surface of Mars.
Shane would like to know, how far has the rover dug into Mars' surface?
We've been able to look under the surface of Mars 2 times. Once with the Phoenix lander, which landed near the North Pole of Mars, and it had a robotic arm with a scoop, and it was able to dig about 16 centimeters under the surface. And not very deep, but we were able to find water in the form of ice right underneath the surface of Mars. The Curiosity rover has a drill at the end of its arm, and it's able to reach out and drill down in. And the drill hole is about the diameter of a dime, and it drills down about 6 centimeters. And from that drill hole, we take the little powder that comes out, and we're able to take that powder only about the amount of an aspirin, and we put it inside the belly of the rover where there's all the scientific instruments. And with that little bit of powder, we're able to analyze those rocks and understand how they were made and what they're made out of. And really, that's how we're uncovering all the secrets of how Mars has formed and changed.
Hi, my name is Ryan, and I go to Cynthia Mann Elementary School. And my question is, how far away is Mars?
The distance between Earth and Mars changes all the time because they're both orbiting the Sun. So they can be relatively close to each other or pretty far apart. So right now, Mars is almost as far apart as we will be, almost directly on the opposite side of the Sun. Today, it's 351 million kilometers away. And one of the challenges about Mars being so far away is it's really hard to drive robots on the surface of Mars when it takes so long for our signals to get there. Right now, the speed of light, it takes about 19 minutes each way for our signal to go from Earth to Mars. So what that means is that we can't drive the rovers with a joystick or with a remote control like you drive a remote control car. We have to send up commands to give the rover a whole day's worth of things that we want it to do, and then it can send back that information to us. So because Mars is so far away, it makes operating our robots and probes and other spacecraft pretty challenging.
Scientists use rovers like Curiosity to study the surface of Mars, but it takes an amazing amount of engineering to get them there in the first place. So let's learn how Curiosity got to Mars and how it survived its 7 minutes of terror.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
As you know, Curiosity made it to Mars just fine, and it's been studying the surface ever since. You can actually follow Curiosity on Twitter and get your own updates about Mars. Okay, let's go back to your questions.
Hi, my name is Jordan, and I go to Waihi Harbor School. And my question is, does Mars have an atmosphere?
Hi, Jordan. That's a great question. Mars does have an atmosphere. It's very much thinner than the Earth's, though. It's only about 1% of the level of Earth's. It's 95% carbon dioxide, 2% argon, 2% nitrogen, and some other trace constituents. So it's enough of an atmosphere to be a pain that your rover might die if you try to not deal with it during landing, but not enough to really slow you down. That's why we needed all those crazy methods that you may have seen for the landing on Curiosity.
Hi, my name is Ethan, and my question is, could people live on Mars? And if so, how would they?
Hopefully someday people will go to Mars to do some exploration. The way we explored the moon. People will have to take self-contained suits just like on the moon because the atmosphere is not something you can breathe. One of the hard things about Mars is it's really, really far away. So it takes about 8 months to get to Mars. So you can imagine going on a road trip with your family and you're sitting in the back of your car. You'd have to go on an 8-month road trip in order to get to Mars. And then Earth and Mars are only close to each other every 2 years. So you'd have to stay on Mars for roughly 2 years before you could come home. And then you'd have to get in your car and do another 8-month road trip to get back home. So it would be a long trip for somebody. And you'd be able to spend about a couple of years, a year and a half or so, on the surface exploring before you'd return home and you'd be able to see your family again.
Hi, my name is Andrew. I'm from Cynthia Mann Elementary School, and my question is, have we sent animals to Mars?
Thank you for that great question. The short answer is not intentionally, other than we want to send humans someday. And the real issue is we want to find out if life ever developed on Mars itself. And I'm talking single-celled microbial life that might even be there today. So the last thing we want to do is to bring those kind of creatures from Earth, contaminate Mars, and then when we go look for life there, discover that we brought it from Earth itself. So that's the short answer. And this is called planetary protection, by the way, just forward planetary protection. Make sure we don't contaminate Mars till we ask and answer that critical question, did indigenous Mars life ever form on its own?
Hi, my name is Sarah. My question is Mars the most interesting planet besides Earth?
I think Mars is the most interesting planet other than Earth because that's really where I get to go to work every day. One of the things I get to do is I get to drive the Curiosity rover on the surface of Mars. So I wake up in the morning and I drive here on Earth into work, and then I start looking at pictures of Mars. And I really get a sense that we're there and we're driving around and we're exploring and finding new rocks and and new geology and making all sorts of discoveries every single day. So because I actually kind of live part of my life on Mars, I think it's the most interesting planet, other than the one here.
Matt Todd, before we run out of time, I want to ask you a question. Why did you decide to become an engineer?
Well, as a kid, I always loved taking things apart and blowing up stuff with my chemistry set. I had very supportive parents. But what really got me to NASA, my 8th grade year, Voyager flew by Jupiter and Saturn, and my grandmother showed me pictures of this in National Geographic. And I saw these pictures of vast worlds, all the moons and beautiful rings of Saturn and the moons of Jupiter, and I said, that's what I have to do for a living. So I made it my goal. I worked really hard in math and science, majored in aerospace engineering, and JPL was my first job. I got to go right on the Galileo mission to Jupiter, and I never want to work anywhere else.
For me, I really love robots. The thing that I like to do the best is to design and build something, and if that something can do something intelligent for us, that's what gets me to go to work every day. The robot I work on just happens to be on Mars, but there's lots of other great things that people do with robots. They can vacuum your floors, they can drive your cars for you. Pretty soon, robots will be everywhere. So being able to come up with new ideas and implement that is just, it's why I love my job.
And if someone's interested in doing this for a living, what should they study in school?
People who want to build robots really are engineers. There's mechanical engineers, computer scientists who make the robots think, and electrical engineers who give the robots the power. And those three types of engineering come together, and you can really help a robot do something. But you have to have scientists here at JPL telling us what we want that robot to do. If we didn't have geologists and atmospheric scientists and geochemists, we'd be just driving around on the surface of Mars taking pictures. And it's really the intersection of engineering and the scientists that help us make these amazing discoveries on the surface of other planets.
And for our students in grades 4 through 12, this is a critical time for you. You will start being able to choose your own path, your own classes in middle school and high school. And it's important to follow your math and science as much as possible. And that opens up these really fun, stimulating STEM careers for you: science, technology, engineering, and mathematics.
Matt Todd, I'm sorry we've run out of time. I'd like to thank you both for answering students' questions. And my thanks too to the Boise Art Museum for letting us come here and explore. You can learn more about Mars and lots of other scientific topics on the Science Trek website. And we'll answer more questions about Mars on the Science Trek, the web-only show. And if you want to submit a question to Science Trek, it's easy, and you and your class can win prizes. You can send it as an email or as a video question, recorded on your webcam or cell phone. And if you're an educator, we'll even lend you a camera. Our last prize winner was Maya from Miss Armblaster's class at Birchwith Primary School in Staffordshire, England. So to find out all about Mars and how to send in your questions and how to win, go to the Science Trek website. And each week, check out my blog for the latest science news for kids. You'll find it all at idahoptv.org/science-trek. Thanks for joining us. We'll see you next time on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/science-trek.